I'm gonna start the recording. All right, welcome to workshop day number 2. All right. Before we get into anything new, I just want to do like a little recap of yesterday real quick. So here you go. Let me know if that's large enough. All right. So I want y'all to give me the mean. I want y'all to give me the median, and I want y'all to give me the standard deviation. All right. Go ahead. I want you to square root it. Yeah. You got the calculator?
No, but my sister did have one. I think it's a TI 36X. X.
That's the one I want.
That's one.
Yeah, that's the one I want.
Yeah.
Perfect. That's the one. That's the one. That's gonna change your life, man. I promise you. When we get into deeper questions, you're gonna see. I remember that calculator too, man. When I was in high school, that was my first calculator. Yeah. But you see, when I came to BCC, they came out with that one. That one is like pre-programmed with a whole bunch of stuff. You do a lot of things with it. Yeah. So like the reason why I'm recommending it too. So I'm not really a fan of the charts. You know how we have the formula packet. So I love the first sheet. You know, the front and back. I love that first sheet, right? But the charts that's in the back, I'm not really a fan of those.
Yeah.
You know, so like that's why I like to use the calculator for those. You know, well you're gonna see. You got a formula sheet?
The formula to no. Thank you.
I'm just leave this right here. Things that else comes in. Oh, you get it. I'm sorry. I'm just asking for it. I don't know if they need it just in case, you know. Maybe like today I asked for it and tomorrow we won't need it kind of thing, you know. I mean, as long as y'all write it down once and then y'all just y'all could probably just get away writing your names after that. But like just for like one time so they could at least say like, okay, I seen on this time sheet who it was, you know.
For the professor, you didn't.
No, you're a professor that you took last semester.
I'm gonna just put it last thing.
That's fine. That's fine. Yeah, you don't need the first name. Yeah. Who was it?
Some guy named CC. Professor. He's the one with he had like black, like kind of like
Caesar, you mean?
I don't know, but he's black. He has like some kind of accent. Like when they think accent, like it sounds like a French accent. Oh no.
So he's African.
Yeah, like African.
Okay. I don't know.
And he's bald too. He's left-handed.
I'm trying to think who that could be. What's the last name?
It starts with T. That's what I remember. But I feel like if you see him, you'd be going home. I might be picturing it as video.
Let me see. I can't say I know everybody, but maybe I could find something. I'm gonna give y'all a few minutes to just do this real quick, you know? Just a little bit of a review before we jump into something new. So you saying that the last name starts with a C,
Yeah,
like Cisse?
yeah, yeah.
Got you. First name is Almy, Almamy. Yeah. So you spelled it right? Cisse? So you good. You good to go. I might have seen the person, but I don't like know the person. You know what I'm saying? All right. Anybody got any questions? So y'all making doing good. You got the mean? All right, good, good. What about the median?
The media, I don't know.
All right, good. All right, cool. And this is clear that this is like five different numbers, right?
Yeah,
This is clear. All right. Good.
oh,
Yeah, that wind is real, man. Came out of nowhere. You got everything? All right, cool, cool. We're gonna go over it in 1 second. We'll go over it in 1 second. Let me just find something real quick. All right, let's get it real quick. Let's get it real quick. All right, so I want the mean. How I do that again? I don't remember.
So, it's the, like, sum of all values, right? So it's like, you basically add all of them up,
Uh-huh.
and so you get 1,778.
Okay,
And then you divide by five.
so sum of all values,
Yeah, and numbers of values. Divided by-
and then the count of how many values, right? Perfect. You said the sum was what?
1,778.
1,778.
Yeah.
Do we agree? Agree? All right. And then we, mm-hmm,
Because the income account and the added of the numbers, like,
mm-hmm,
and then I divided by the numbers.
mm-hmm, very good.
And the 355 and 6. I don't know after the 26 if I support it now.
Me personally, I don't like to round. Right. I just write everything. Yeah. So what you got? 355.6 what?
That's it, that's.
That's it? That's it? What about you? All right. All right, so we good on the mean. All right, so to find the mean, we sum all the values and divide by the count of how many values are there, right? On your formula sheet, chapter 3, the formula is right there where it says sample mean, right? So we don't gotta memorize it, it's right there, right? How about the median? How we do that?
Like, that's like posting out four numbers, so once you get to the bottom, like, you go left and right, until you
Uh-huh.
get to the number 164.
Okay.
And you should basically posting out right and left until you get the right.
But what am I supposed to do before I cross it out?
Oh, you're supposed to label it, in order, like 90.
Put them in order, right? All right, so let's put them in order real quick. Give me the order. 91, 142, I heard. 164, 541, and 840. All right, that's good. That's good. All right, and then we just kind of cross them out, pop, 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 and then that's my median, right? We agree? Yes, we're good. Awesome. How about the standard deviation? How we do that?
That's very good, that's like taking out all the numbers from when this is and subtracting it with the remaining of the mean. And like 840 minus
Uh-huh.
350,006. And then you get like basically.
So you're making a chart,
Yeah.
right? Okay. So which one, which chart are you using?
Standard deviation.
No, so remember there's two ways to do it, right? There's one where we do the x and the x squared, and then there's the one where we do the x minus x bar, right? And then x minus x bar squared, and then like that takes more time. Which one are we doing? X and x squared? All right, let's do that. So for the x, what are my values for x again? 91, I heard. 142. 164. 549. 541. 840, good.
And that total right there is gonna be 1,778.
1,778. Awesome.
And then for your square,
Yep. What's x squared?
it's gonna be 8281 for 91.
8281.
2164. 1,164.
Uh-huh.
No, 20, and then 164.
Got you.
20.
Like that?
Yeah.
Okay.
And then 26,896. And then 29,002. Wait, no, I put you that, sorry. 292,681.
Okay.
And then 705,600. And then the total for that is gonna be equivalent to 1,053,622. So 1,053,622.
Do we agree? You look like you copying, so you scary. You did it the other way.
Yeah.
I did it the other way too. The other way? All right. All right, we could definitely check that out. Let's see if we fit when we finish this way. Let's see if we get the same answer.
Okay.
All right. But we will look at the other way as well. All right. So what's the variance formula here? You can, so s squared is equal to
square root
the sum of x squared minus
x
the sum of x, right? Squared
divided by n
okay.
over n minus 1.
Perfect. All right. And all we got to do is just plug in those numbers. All right. We're gonna do it your way too, though, see to verify. But we should all get the same answer regardless. Yeah, regardless of whichever way we doing it, we should all get the same answer. All right, so I'm gonna plug in the numbers. All right, so I got the 1,053,622. I'm only using the commas just to make it more, pop towards us, minus the sum of x, which is 1,778 squared divided by 5 and then divided by 5 minus 1. All right? And then when you do that, what do you get?
3161 284.
Just like that? So 3,161,284. A whole number, no decimals? All right. So now, yeah. But I'm gonna verify it in the calculator anyway. So but I'm listening to you though, and I'm writing out what you tell me.
So like even though we're doing you're like so me and him only in the phone over there.
Yeah.
Me and him probably did it like a different.
Y'all did it the other way. Yeah.
Oh,
Yeah. I just feel like this way easier.
okay.
Because like all I gotta do is take the X's, which I already have, square them, light work, add them, and just plug it into this formula and call it a day. It's a harder way, but it will give you the same answer.
Oh.
Yeah. No decimal? All right, cool. So now what I want the hold on one second. I want the standard deviation, S. And how do I get that? I have to square root the variance. Right? So in my case here, I'm going to square root the 3,161,284. What do I get? I lost you.
You square root your first. I thought you do that to the end.
This is the end. Yeah.
This is the way I do it.
Mhm.
I didn't know you was doing it all together. I just thought you was square. I thought you was square root of this, and you want to square. Yeah, I thought you wanted to square. Okay, that's why I gave you this number. This number is wrong. So you telling me that this number is this number? Yeah, I get what I'm saying. This number is this one. Yeah, so this is the number right here. It's gotta be like.
That's what I want. Give me that number then. That's what I want.
My fault.
Yeah.
105.
105,000. Okay.
341.
341.5. All right. So then that's what I'm gonna square root down here.
Yeah.
So 105,341.5. And what did you get for the standard deviation now? After you square rooted it.
224.55, 5635.
5635. All right, confirm with me. Did you guys get the same answer for the standard deviation?
No, we got to
Completely different?
So
Let's take a look real quick.
before I don't want to delay your class even more.
I get you.
So see, I square rooted this number.
Good.
And I square rooted this number. This is the equal. It's 290.3.
Got you.
But I don't know. This is the one.
Well, let's verify it. We're gonna verify it right now. All right. All right, let's take a look at what I get when I do this. All right. I'm gonna start all the way at the top. Just want to verify I got the right numbers here. All right, so X. I'm not gonna do it in the same order, but it should match. You know. Well, matter of fact, you know what? I'll do the median. I'll do it in that order. But just know that when you're doing the standard deviation, you don't have to do it in the median order. You could do it. You could take the original question and do it. All right. So real quick, and then after I verify this, we'll do it your way. All right. All right. So numbers is checking out. This is, I know it's kind of small. This is me. That's what we did right here. All right. Numbers is checking out so far. All right. Let's look at the sum of X. All right. Let's see how we looking right here. Hold on. Oh, don't freeze on me now. Let's go. I know it's cold in here. All right, so I got 1778. We good. Good with that, right? All right, let's take a look at the x squared. So I'm gonna square each one of these numbers. Let's take a look at that. So the 8281 checks out. Let's look at the rest. Oh Lord, listen to me. All right, so I got the 2164 good, 26896 good, 292,681. Good. 705,600. Perfect, perfect, perfect. All right, let's look at the sum of x squared. All right. Look at what we got here. So I got 1,053,622. Perfect. All right. So we on point with that. All right. Now let's take a look at our variance. All right. So if we know that that's right, then our variance got to be right. Bop, 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 bop. Okay. All right. So what that's telling me, right, is that maybe we might not have typed it in right in the calculator. So let's talk about how to type this in the calculator. All right. So I'm right here. First thing I want y'all to do, right? You're gonna this is for him. Which calculator are you working with, by the way? Yeah. The same one he got? Yeah. All right, we're gonna do a separate lesson on that, right? So this one's for you. All right. So now to type this in the calculator, right? First thing I want you to do is I want you to hit the fraction button. The fraction button. Let me see if I could get that for you real quick. 1 second. Hmm?
I did the premise with.
No,
Not supposed to.
no.
That, she said.
Yeah, he said, yeah, he right. But what year are we in? I don't even know what year it is anymore. Like we beyond that, man. That was high school. Hmm.
Not supposed to.
I'm gonna show you how to do it. Hold on. Just bear with me 1 second. You might have done it right too. You might have done it right too. I'm going over this because we got two different answers.
Okay.
Yeah, but y'all, one of y'all is right. I don't know who's right, but one of y'all is right. All right, let me get my lavender eye, my pink. All right. So we got the calculator here, right? First thing I want you to do is I want you to hit the fraction button. That's the fraction button right there, right? So when you hit the fraction button, what's gonna come up, right? It's gonna be something like this, like a little square over a square, something like that, right? So in that top square, in the top square, we're gonna write down the number that we have. So that's gonna be the 1,053,000. What was it again? 622? 622? All right. Then you're gonna hit the minus sign, right? Here go the minus sign right here. Let me show you. That's the minus sign right there, right? And you're gonna hit that minus sign. But check this out. Check this out. Right before you enter in the next number, right? You're gonna hit that fraction button again, right? You're gonna hit that fraction button again right here, right? So now we hit the fraction button again. Now you're gonna enter in the 1,700 and oh shoot. Who remembers what that number was? I forgot. Yeah, 1778. Good. And then you want to square it. Here go your square button right here. See that square button? There's your square button right there. Then you're gonna want to square that, and then below it, you're gonna press down. You're gonna press 5. Then you're gonna press down again, and then you're gonna write 5 minus 1. Then you're gonna hit enter. You're gonna give me the answer.
Same answer.
Same answer. All right, so maybe you're right then, man. Maybe you're right.
I don't think this makes a difference though, but it's still 105,341, but instead of 0.5, it's 0.3.
Then that's the difference.
That's the difference?
That's a difference. All right. It's just that 0.3, nothing else. All right. So now after that, now, right, we want to square root that, right? Because remember, this our variance right here. This that s squared. But what I want in the question is I want the standard deviation. So we're going to square root the s squared, which in this case is going to square root the 105,341.3. And that's going to give me what?
324.563.
Hold on, I heard 324.
563.
That's it? All right. And then, the square root, there go your, you press second, and then there goes your square root right there. All right. Not bad, not bad. All right, so we got one answer here, but it's different from what y'all got. The same as what you got?
I got
324.563. Don't round. Just write everything.
Oh, that's why
What?
I rounded it.
Don't round. Give me everything.
So y'all
Boy, you got the same answer, 324?
because I rounded it. That's what I did.
Yeah. You mean you rounded the one?
Oh, all right. So I rounded to 1,553, 662. The first one. It was a minus, that one. I rounded that number.
Nah.
That's what I'm.
No rounding. All right, so let me talk to y'all about this real quick. How do I do that in the calculator? All right. Now, this is why I'm trying to encourage y'all to get this calculator right here. So y'all about to do some computer science real quick. All right, get ready. So to enter into your calculators, what y'all got to do? This is how you do it. First, we got to look at it, right? You realize that there's a numerator and there's a denominator here, right? There's a numerator, there's a denominator. So we got to do parentheses for our numerator, and then we got to do parentheses for our denominator. So first parentheses here, this for the numerator, right? Now what am I going to do? I'm going to write in that number. That's the 1,053,622, right? Then you want to subtract it. And then after you subtract it, now I want to square that term, right? So we're going to do open parentheses. This is going to be the 1778. But then look, inside of that is where you're going to square it, right? So you guys got the caret and then the 2. Close parentheses. Then you want to divide it by 5. Close parentheses, right? So now that's your numerator. That's the top portion of this, right? That's that top portion right here. What we just did. That's that top portion, right? So now we got to hit up the bottom portion. The bottom portion is going to be divided by open parentheses 5 minus 1. All right, do that in your calculator real quick. I'm trying to get the 105,341.3. That's what I'm trying to get. So type that in your calculator. Try that out. Try that out. Which part is confusing?
No, I'm just trying to, I understand where you're coming from. I'm trying to remember based on what, when I did it in my other class.
Gotcha.
I understand.
Because basically what I want y'all to do, right, going forward, you hit me up with the formula, then you plug in the numbers, you give me the answer. I don't want this in the middle, like, oh, let me multiply this first before I start. None of that. You type in everything, you click enter, you give me the number, and that's it. All right. How we looking? You got it? You got this? Like you typed it in, click enter, and you got the number?
Oh,
That's what I want you to do. Type it in the calculator, click enter, and give me the number. Yeah. No, no, I want you to type this in, right? And I want this answer out. I want this 105,341. I want this, but I want you to see it in your calculator. Oh, that's what I'm trying to do. Unless you agree that you're gonna get the other calculator.
Huh?
Unless you agree that you're gonna get the other calculator.
Agree?
Like I'm saying, unless you agree that you're gonna get that calculator, the other one.
Oh.
All right, you got it? I don't. Syntax error? All right, so something that we typed in wasn't right. So let me take a look. So clear it out real quick and let's see. So open parentheses. One. No, not. Just matter of fact, just give me the number without the comma. Right, 053 622 minus open parentheses 1778. Ready to see the second? Right. No. Here we go. Second. Close parentheses. Right, divide. Five. Close parentheses. Open parentheses. Or no, divide or something. Open parentheses. 5 - 1. Close parentheses. Enter. That's what we see. All right. So then now that you got that number, right? You can now square root it. All right, so let me just write it in real quick for our sake. And then now you can just square root this number. And then that'll give you the standard deviation. All right. So go ahead, the second square root. Oh, oops.
We have a calculator to get how much.
All right, so let me on the second square root. Perfect. I'm going to show you the second. Include on the movie was the answer. That's copying the paste. Yeah, so that way you don't gotta retype around all that. And then that's it. What you got? What you got there for your number though? 3 what? Oh, this one? Yeah. 3 2. 3. Oops. 3 2. Uh-huh. Mm-hmm. 5 6. 3 2 what? 3 2. Mm-hmm. 45.
So, and the calculator, you
It's
got it with
perfect.
the comments, right? Or you don't have?
No, no, no comments, no
All right.
comments. Oh, you got the right calculator. I thought you said you got his calculator.
Oh no, I thought from a long distance because I thought the way it was built.
Oh, the
Yeah,
Apple phone. Nah,
yeah.
nah, you got his. That's the one I want you to have. That's
Oh,
better. So,
okay.
so the what you heard me talk about before when I was like, oh, press the fraction button and all that. This is you. It's your calculator right here.
Okay.
All right. Yeah. Yeah, man. You gotta upgrade, man. You
Yeah.
gotta upgrade, man. I'm telling you. Remember, go to the Staples website. You find out where it is, right? Like where they have one. Then you go there, you get it. But remember, also look online, Amazon, Walmart, find a cheaper price, right? And then they'll price match it at the Staples. Mhm. Mhm. Yeah. It I ain't gonna front. It is cold though. Like that's why I'm standing. No lie. That's why I'm standing. Listen, I was over bro. I keep it 100 with you. Like he is coming through right now. I don't know how air is getting through the glass.
You guys think about it. You use the glass too. Some glass are thick, some are like cheap. Yeah, I'm telling you.
This thing don't feel like he's coming through.
Nah, coming through, get a little bit.
Yeah, in the back when you sit in this heat. I mean, there's a little bit of heat right here coming through.
Now, I'm not gonna lie, he shot his best, because I don't believe him, because I gotta be another in the hole.
Yeah.
I didn't even want it to come out my curtain.
Nah, yesterday I understand that because with the snow and all that. All right, so just checking again. So we good
Yeah.
with the mean, the median, the standard deviation, right? All right, good. Y'all need to see the other way, or we can move on.
No.
Move on. All right. Go ahead.
Like for this course, right?
Mhm.
You only giving us homework and stuff, right?
Mm-hmm.
So that only added to like.
Your grade? No. The point of the homework is to prepare you for the final. Yeah.
How many starts for an hour?
The same time as before.
Oh,
Yeah. Basically like your class time here. That's the final time.
oh. And then over.
I'm sorry? The 16th next week, Thursday. Yeah.
Oh,
So look, we got a story right here, right? So the manager of a salmon cannery, I don't know if I'm saying that right, suspects that the demand for her product is closely related to the disposable income of her target region. To test out this hypothesis, she collected the following data for 5 different target regions, where X represents the annual disposable income for a region in millions of dollars, and Y represents the sales volume in thousands of cases. All right. So let me write those out real quick. Just bear with me 1 second because it's not gonna look pretty. I'm gonna try my best. All right. So I got my X and I got my Y. 23, 2, 26, 1, 15 and 9, 35 and 9, and 5 and 8. Just verify real quick. Okay. Okay. Here's what I want from you. All right. Give me a scatter diagram. I want you to tell me, right? For part B, I want you to tell me what is the correlation, like the sign of it, right? Is it positive or is it negative? For C, I want you to interpret your results. Go ahead, do that real quick. Oh, my fault. Hold on. Forgot to, didn't realize I was blocking the story a little bit. My fault. Include the story with it. Mhm. You know what? My fault. Made a mistake on one of the numbers. My fault on that. No, just one number. My fault. This was 19. That was my fault. My fault. Sorry about that. Remember how we scattered right here?
That's the one with the dots, right?
Exactly. That's what I did.
And you can put that towards the calculator too, right? I don't remember how to put that in the calculator.
Can't.
Oh, you
You
can't,
gotta
right?
do the graph.
Oh, yeah.
Graph, that's what I'm.
Oh. My bad, I'm in 3 weeks about, man.
It's all good. It's all good. Yeah. Like it's not bad. Like until the wind blows. That's what makes it bad.
Yeah, that's, you know what's crazy? Because they talked about there's like a snowstorm approaching too.
Wasn't that yesterday? There's another one coming?
Yeah, there's supposed to be another one.
I think it's cool.
I mean, not too many weeks ago, they were saying how we had a drought in the city, right? And we needed water, so the snow sounds okay. Now, keep it 100. Yesterday was cold, but it wasn't like this cold.
Yeah, it was not this
You know?
I think it's the wind.
Yeah,
But I'm not
The
gonna
wind
lie,
is bad.
yeah.
if you know, the winter island isn't that cold though, like compared to other years. Like other years, you still have to wanna go outside and like the things would be like freezing to the death.
Mhm.
It's to the point where you feel like, oh, walk through it.
I feel like in my opinion, it's been like it feels cold outside, but we haven't had like snow in a minute.
Yeah.
You know, and when we do get snow, it's like a little sprinkle, and that's it. It's not even serious. You know?
We outside, we outside. I don't even know what's that done, that's how serious it is.
I feel you. By the way, you guys, I'm just kind of repeating it for you now. So there's also tutoring available,
Oh,
right? Tutoring has two modalities, both in person and online. You can attend whichever one you like.
oh,
All right.
the in-person, we did that.
It's right here, 303. Like you have to like walk past it to get to class, you know? So it's a win-win. Yeah.
How long did that? For like,
It's from 12 to 6 every day.
oh,
Yeah. So if y'all want to go there, do some practice after class, and then you can go home and chill, or if you just want to like dip, and then when you're at home, you just go online and do some stuff, like that's cool too. Yeah. Are we done? We good?
yeah,
You did all three, right?
yeah.
All right. Let's try this out real quick, right? So first things first, I want a diagram. Bam, just like that, right? This is my x-axis, this is my y-axis, right? And then X is what again? Let me see. So X is income, Y is sales, right? So right here, this is income, this is sales, right? And then now we want to make our axis. So remember, what the goal with making the axis is you want to include every number, especially the biggest number, right? So my biggest number here is 35. So now I have to figure out in my head, how am I going to get to 35? I could go by ones, go by twos. It's up to you, right? I see 35 and I don't know why, but five just pops in my head. Yeah, so I feel like I'm gonna go by fives, right? So we know that right here
So it's like,
is zero.
oh,
Yeah, so this is gonna be 5, 10,
15, 20.
15, exactly, 20, 25, 30. I'm gonna just cap it at 35. I could push it more, but I'm gonna cap it at that. And then I look at these numbers now, right? So I'm going from like zero all the way up to 19. And I could do it however I want. I could go by twos, I could go by tens, I go by whatever, Right? I feel like I'm gonna go by
I thought it was 2.5.
2.5.
Yeah.
No, because look, the smallest number is one. Yeah.
But like I said, like you have zero, you start with zero. I start
Yeah.
with zero, right? But then like my second number was like 2.5, 5.0, and
That's fine. You could do it that way if you want. Yeah, you could do it that way. I think I'm gonna do. I'm thinking. I'm gonna do twos. I feel like I'm gonna do twos, right? 2, 4, 6, 8, 10, 12. Ran out of space. 14, 16. Woo, twos might not work. You did it by 5? All right, I'll do it by 5. I could do it by 3s. All right, let's do it by 3s then. 3, 6, 9, 12, 15, 18. And then what's that, 21? All right, let's do that. Appreciate that, man. Thank you. Now, you guys could do dots. Me personally, I'm a fan of X's. All right. So my first number, 1 second. My first number is 23 and 2. So I'm gonna come across to 23. I'm gonna go up to 2, which is gonna be somewhere like right here. My next number is 26 and 1. Come across to 26, go up to where 1 is. It's like right here. My next number is 15 and 9. So I'm gonna come across to 15, go up to 9. It's like right here. Or the wind, right? And then 35 and 19. So 35, 19 is gonna be somewhere up here. And then I have 5 and 8. I'm sorry?
Oh, it's just 21 on the dot.
It's not gonna be exact.
Okay.
It's not gonna be exact.
So it's like, that's what I said.
Yeah. So the idea here, right? We're not computers, so we're not gonna get the exact point, right? But eyeball it, like 21 is in between 20 and 25, so no, it's gonna be somewhere in between that. It's gonna be closer to 20 than 25, so just do your best. Do your best, All right. Would you say that this correlation is positive or negative? I would say negative. I would say negative. So basically, if I was to draw a line of best fit, my line of best fit would kind of go more like here. Because you see how the numbers, the points are decreasing from left to right? Even though we have one extraneous point over there, it's decreasing from left to right. Right? So I would say that this is negative. Right? So that would be this is my graph. For part B, I would say negative. Let me ask y'all a question though for C. What's the interpretation? As X, which is your income.
That's
Increases. Increases. Y, which is your sales. Decreases. Very good. That's perfect. That's well done. Well done. Well done.
Oh, so that's the only thing you have, all right, that
Yeah.
understand, see, I'm reading something like that, but I just didn't understand. But
So-
it's exactly like that.
That's it. Yeah, that's the exact same thing, right? So what you're gonna say, right? Always, as X is increasing, what is Y doing? If it's negative, Y is decreasing. If it's positive, Y is increasing. That's it.
Okay,
But use the story with it though,
okay.
right? Use the story with it. But see, as X is increasing, Y is decreasing.
Okay.
But you should say, as income is increasing, sales is decreasing, something like that. Yeah. Interpretation. Yeah. Oh, when you get a chance, you could like sign it for me. Yeah. All right, bet. So we go with the scatter plot?
Yeah.
Good? All right. We just recapping from yesterday. But now we about to jump into something new. It's about to be fun. Uh-huh. Yeah, eat. Go ahead. All right, so now we're gonna jump into probability today. All right, jumping into probability. So we're gonna look at some probability rules, compound events. Good stuff, good stuff, good stuff. All right. Interpret some of this for you. So we're going to talk about conditional probability and multiplication rules. So let's say you roll two dice. What is the probability that you will get a 5 on each die? Consider a collection of 6 balls identical in every way except in color, right? There are 3 green balls, 2 blue balls, and 1 red ball. You draw 2 balls at random from the collection without replacing them, right? The first ball you draw, excuse me, the first ball before drawing the second. What is the probability of both balls will be green, right? These are compound probability events, right? That's what we're talking about. Let's elaborate on this a little bit. And then we're going to look at some examples. All right. So it seems that these two problems are nearly alike. They are alike in the sense that in each case, you are to find the probability of two events occurring together. In the first problem, you are to find the probability of getting a 5 on the first die and a 5 on the second die, right? In the second, you want to know what is the probability of getting a green ball on the first draw and then a green ball on the second draw, right? But they're different though. They're different. Mhm. The two problems differ in one important aspect. However, in the die problem, the outcome of a 5 on the first die does not have any effect on the probability of getting a 5 on the second die. Because of this, the events are independent. All right. So when one experiment can happen by itself, right? And it doesn't affect the outcome of another experiment, that's considered independence. All right. When one event happens and then it's affecting the outcome of the second event, that's dependency. Okay. Just want y'all to understand the difference so that when we get into the questions, y'all will know what I'm looking for and what we're gonna do, right? All right, so two events are independent if the occurrence or non-occurrence of one event does not change the probability that the other event will occur. All right, let's take a look. So in the problem concerning a collection of colored balls, the probability that the first ball is green is 3 out of 6, right? Because 3 of the balls are green and it's 6 total balls, right? Since there are 6 balls in the collection and 3 of them are green. If you get a green ball on the first draw, the probability of getting a green ball on the second draw is changed, right? Because now I took out 1 green, so I only got 2 greens left, and there's 5 balls to choose from now, right? So 3/6 and 2/5, right? So, and again, because 1 green ball has already been drawn and only 5 balls remain, therefore the two events in the ball drawing problem are not independent. In fact, they are dependent, right? Since the outcome of the first draw changes the probability of getting a green ball on the second draw. All right. There's some good stuff right here. Good stuff. Mhm. So why does the independence or dependence of two events matter? The type of events determines the way we compute the probability of two events happening together. So if two events A and B are independent, then we use the formula to compute the probability of the events A and B, right? So anytime you hear the word and, right? Automatically in your head, what should pop up is multiplication right here. This is the multiplication rule for independent events. So the probability of A and B is equal to the probability of A times the probability of B. All right. Anytime we hear the word and, multiplication. Just remember that. And multiplication. Formula sheet. Look at chapter 5, right? On the formula sheet, right there at the top, right? Well, not at the top. Hold on, let me get one of these. Kinda, yeah. Chapter 5 at the top, where it says general multiplication rule. That's what we get into. That's what we get into. All right.
But it says like P on P and A and B, right?
Right.
Uh,
Probability of A and B.
oh,
No. So I'm getting to the one that I want you guys to use. But I'm building it up though. I'm building it up. So if the events are dependent, then we must take into account the changes in the probability of one event caused by the occurrence of the other event. This is the type of question you will get on your final, a dependent question. All right. The notation probability of A given B denotes the probability that event A will occur given that event B has occurred. This is called a conditional probability. All right. We read the probability of A given B as probability of A given B. If A and B are dependent events, then the probability of A does not equal to the probability of A given B because the occurrence of event B has changed the probability that event A will occur. A standard notation for probability of A given B is probability of A given B. So on your formula sheet, it's written as this. A/B, right? But it means A given B, all right? This is the formula I want you to use for your final. The general multiplication rule for any events, right? The general multiplication rule for any events means that it works for all situations. That's what I want y'all to use. All right. So probability of A and B is equal to probability of A times probability of B given A. Or if you like the other one, probability of A and B is equal to probability of B times probability of A given B. Personally, I just stick with the first one and I just run with that. You know? Again, on your formula sheet, chapter 5, where it says general multiplication rule, that's where you see it. Hmm?
so that is what.
Mm-hmm. When you're doing the questions, all right? So let's look at some examples. So multiplication rule for dependent events. Consider a collection of 6 balls that are identical except in color. There are 3 green balls, 2 blue balls, and 1 red ball. Compute the probability of drawing two green balls from the collection if the first ball is not replaced, right, before you draw the second. So what that means is like I have the balls in the bag, for example. I'm gonna take one out. I'm gonna write down what I got. Then I'm gonna put my hand in the bag again and take out another ball. I'm gonna write down what I got. All right. So let's take a look at how we do that. Did you get your calculator, by the way, man? Okay. All I want to know is which one you got. That's all. Awesome. All right. As long as you got it, then we good to go. Yeah. 36X Pro. Yeah. As long as you got it, then we good. All right. So let's look at the multiplication rule method for solving this, right? These events are dependent. The probability of a green ball on the first draw is 3 out of 6. But on the second draw, the probability of a green ball is only 2 out of 5. Right? So if the green ball was removed on the first draw, right? So by multiplication rule, this is how we do it. Probability of the green on the first times probability of the green on the second, given that you drew a green on the first, right? So that's going to be the 3 over 6 times 2 over 5. Little multiplication, bop, 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 then you get in the calculator. 0.2. And that's it. That's all I want. Yeah. That's all I want. This makes sense? Cool, cool. Just to overemphasize it, I like to repeat myself. All right. The multiplication rule applies whenever we wish to determine the probability of two events happening together. To indicate together, we use and between the events. But before you use a multiplication rule to compute a probability of A and B, you must determine if A and B are independent or dependent events. I'm telling you on your test, you will have dependent events, right? You wish it was independent. Independent means you just multiply the two numbers together and that's it. You're going to have to identify which two numbers you're going to multiply. That's the trick. We're going to get to it. Don't worry. We're going to get to it. Let me just give y'all a little procedure real quick. This that recipe, how to do it. So how to multiply, how to use multiplication rules. So first determine whether A and B are independent events. If the probability of A is equal to the probability of A given B, then the events are independent. All right. If A and B are independent events, then you have probability of A and B is equal to probability of A times probability of B. If A and B are any events, that's the one that we're going to have on our test, any events, the probability of A and B is equal to the probability of A times the probability of B given A, or the probability of A and B is equal to the probability of B times the probability of A given B. All right? Number 3 is us, in case you're wondering. Before I jump into the next example, I want to give y'all the meaning behind all of this, because maybe if you on your test and you forget, maybe the meaning will come back and be able to help you. So real quick, what does conditional probability tell us? Conditional probability of two events A and B tells us the probability that event A will happen under the assumption that event B has happened or is guaranteed to happen in the future. This probability is denoted by probability of A given B and is read as probability of event A given event B. Note that the probability of A given B might be larger or smaller than the probability of A. The probability that event B will happen under the assumption that the probability, under the assumption that the event A has happened, This probability is denoted by probability of B given A. Note that the probability of A given B and the probability of B given A are not necessarily equal. All right. If the probability of A given B is equal to the probability of A, or the probability of B given A is equal to the probability of B, then the events A and B are independent. This means the occurrence of one of the events does not change the probability that the other event will occur. Okay. And then one last thing before we look at another example. So conditional probabilities enter into the calculations that two events, A and B, will both happen together. The probability of A and B is equal to the probability of A times the probability of B given A. Also, the probability of A and B is equal to the probability of B times the probability of A given B. All right? And then you can forget about the rest. All right? Leave that up there for a second in case anybody wants to copy. Okay. 1 second. All right, do this for me. Just checking. Everybody got an email from me yesterday?
Yeah.
Just checking. How about Brightspace? Can you guys see the class on Brightspace yet or no?
No.
Yeah, first we gotta find out if it's on. When
I'm telling you, it's dependent. They will always and forever ask you dependent questions on the final. On the final, they will only ask you dependent questions.
didn't you just say on the final?
Dependence questions. You wish that they were independent. That's what I said. Because if it was independent, let's multiply two numbers and call it a day.
I don't know. The good one. I'm just saying, you know, the good one. And I'm surprised I didn't even back that. I did. Oh, I did. That's good.
Now to get here, it's like you like.
So what happened? I didn't
was
know.
fast. It was the final of this year.
That's what, see, that's what I was thinking, cause my grade in math, honest to God, it was a B plus.
Yeah.
That's what happened, and the final just like tanked you.
Like 35% of that shit, I'm like, hold on.
Yo, bro, I'm not gonna lie, it was like 3 days later, I get it, because all my homeworks are completed, but you know, the homeworks is nothing, I'm like, they're based on percentage. So 2 days later, I'm seeing, I'm like, I got like it's sure I had like a B plus. And then I got his email a couple of days, ago. I'm like, wait, so why is that how I need this class, if I got a B plus?
Exactly.
And then comes up front, like I had a D, I'm like, what the fuck?
That's because the finals 40%.
But I had like, but I had a D, I had a D, and then once the final was presented, it showed like I'm doing minus. So I was like, what the fuck? And then I'm thinking like, whole time it was my test is come to find out it was my final.
It also depends on like which major and stuff. Some people's majors, like you gotta get like a.
Yeah, my major, I need a C, for that. Yeah, I need a C.
I know it is going that hard and shit.
Yeah, it's playing.
Are you nursing?
Nah, I'm criminal justice.
What you wanna do with criminal justice?
I wanna be a lawyer.
That's fine.
Yeah.
It's fine.
I'm tired of what they be doing with certain innocent people.
Yeah. Stick around after class, though. We'll talk about law. Yeah. I feel like criminal justice is not the right nation.
Yeah.
I have like other ideas I can tell you.
What part of my future?
Mhm.
This is like, this is like professor, that was from, regional college of, Syracuse.
Okay.
So when I was in Syracuse, a professor.
You know, that's where Joe Biden graduated from, you know.
Neither one of them.
Donald Trump, I was actually right down the block. He's for them. Oh yeah, that's true. That's true. I mean, but now you in CUNY, you know, Bernie Sanders, right? Yeah. BMCC, Cardi B.
Yo, Baruch College, you know. Nah, that's fine.
City College, Ralph Lauren, Polo. Are you just making this up?
Nah.
Say this thing. Listen, mad people, like mad big people graduated from Cuba, man. Matter of fact, yo, let's talk RFK Jr., right? You know how RFK Jr. wanna get rid of the polio vaccine, right? I don't know if y'all heard about that, but there was this issue back in the day called polio. Mosquitoes used to bite you and used
Yeah, I
to
heard about
cripple the kids and all that. One of our presidents had it. Roosevelt had it, right? So long story short, right? There was like a arms race, for lack of a better term, to come up with a vaccine, right, for polio. All right, so the dude that came out with the polio vaccine, that's City College. I mean, he went to NYU. He went to City College first. Mhm.
This couple is down to batteries, right?
Nah, it's solar. You just put it under the light. It's solar right here. Let me see if it's the wind, man. Like this shit is crazy. It was tomorrow's supposed to be like hotter or colder than here. It's tomorrow's supposed to be hotter or colder than this.
It's supposed to be cold out.
Nah, I'm dead about to ask if we can do something.
So where? No.
Oh, pencil.
Oh, you're available. I'm out of here.
Yeah. I mean,
No.
let me.
The water looked like 3 times.
I mean, let me ask y'all a question though. Like, if I ask them if we could push this online, would y'all come online, or would y'all rather in person?
Nah.
What about y'all?
I got the final answer.
No. What would you prefer?
Either way.
I'm talking about tomorrow. Yeah.
Like, for the final, I prefer.
Yeah. I mean, like I'm just saying, like if the weather is really bad.
Yeah.
Yeah. Yeah. All right, so let's check this out, right? So at a meeting of the International Astronomical Society, awesome. 58% of attendees are female, right? So the probability of female is 58%. I bet. And 36% are teachers. So the probability of being a teacher is 36%. Given that an attendee is a teacher, 55% are female. All right. So what is that? Somebody tell me what that is.
Oh, 55%.
No, but tell me like in words what that is. Like I'm looking for something given something. Tell me.
It's similar to like the word between, right?
I mean, I'll highlight it if you want to see it, if that helps. That's what I'm trying to figure out. Help me out. Something given something. What is it?
Both.
It's not both.
Oh,
No. We get into that though. We didn't get to that yet. But we get into that. Huh? I'm asking you to translate the highlighted part for me down here. Because I need to write something given something. Matter of fact, I'm gonna help y'all out. I'm put the so you're saying it's female given teacher? All right.
Oh, yeah, I did it like that, but, yeah.
I'm impressed. I'm not gonna lie. And that's it. All right. So anything that comes after the word given is your denominator. All right. All right, real quick, real quick. So you know what they asking me for, right? They want to know what's the probability of teacher, Teach, and female, right? I'm just copying from the last line right here. See?
Oh,
Let me highlight that because that's not looking too good. All right. All right. That being said, the probability of teacher and female is going to be what? Okay, so it's going to be the probability of female
oh, okay, yeah.
given teacher times what?
Wait, is it Tom or me?
Times.
Oh, Tom, teacher.
Good. Does everybody agree?
Yeah.
All right. So here's how I remember this, right? I'm gonna use the green highlighter. Anything that comes after the word given is the one that's gonna stand by itself over here. That's how I remember it. Whatever is after the word given, that's the one that's gonna be by itself over there. So now you just plug in the numbers, light work. All right. So right. And then what's the answer y'all got? Everybody agrees? Everybody agrees? You just saying it or you actually checked it? Ah, check it. Yeah, y'all the one with the fancy calculators. Y'all supposed to be like, yeah, it's right. 0.19 good.
But
Okay.
if you, but if you put it in the test, if you
Uh-huh.
put like 19.8, would they, would it still be more?
19.8%.
Yeah, yeah.
Then you're fine.
Oh.
Yeah. Was 0.198? Perfect. Questions on this?
Yes, I'm still lost.
What's up? How'd I lose you? Yeah. How'd I lose you?
I understand it. Like, it's just like, when you get to that given part, it's where it's been.
All right, forget the story, sir. You got this on your own? No. All right, that's the issue. So then we gotta come back over here with it. So I need you to be able to take the story, break down the story into these pieces, and then put it together. Right?
No, but I thought it was or.
No, it would say or if it was or. All right? Yeah. We get into that though. We didn't get there yet, but we get into that. Get y'all off with another question. Go ahead, knock that out for me.
Hey, Blaine, I'm only walking right now.
This classroom is always not this way. I don't know. I'll see if we can get a swap or something. Maybe something downstairs. All right. I love the desk too. I just don't like the wind in this. There, there, yeah. That room though is warm though. Yeah, it's just us. All right. At a conference, there are 172 attendees. 48% of the attendees are interested in topic A, 47 are interested in topic B. Given that an attendee is interested in topic B, right, 84% are also interested in topic A. What is the probability that a randomly selected attendee is interested in both topic A and B, right? So let's look at this. The probability of A is 48%. The probability of B is 47%. And then what's the other one? Probability of what? Of A given B is equal to 84%. Now I want to know what is the probability of A and B. So that's going to be what? Probability of A given B times what? Probability of B. Very good. Whatever comes after the given is the one that stands by itself, right? And then you just plug in the numbers and that's it. So I got 84% times 47%. Very good. Help me out. What's the answer? 3948. Okay.
Cause I got 3,948, right?
No, 84%.
Oh, gotcha.
Yeah. All right, let me show y'all how y'all do percent real quick. Huh? No. How to do percent. Just bear with me 1 second. Just 1 second. Bear with me. All right, real quick. So I need to copy. 84% times 47%, right? All right. So if I'm gonna do this in a calculator, right? We all know how to do 84, right? Just 84, boom, right? But then you want to press second, and then you want to press percent right here. Right? So that's how you get 84%. And then times and then 47%. Right? But then it's still gonna give you out the decimal answer, which is 0.3 whatever 948. Uh-huh.
So basically, whenever they're gonna run, whenever they're gonna come past a question that's gonna compel us to use P of A and B equals P of B times P of A given B.
That's what this is.
No, the second one, the second one.
But just as long as you're using those two, not the one before, just those two. Right?
If we use either or, it's
Right. Let's take it up a notch. So a little bit different. I want to talk about addition rules. Okay. Addition rules. Mhm. So another way to combine events is to consider the probability of one event or another occurring. For instance, if a sports car saleswoman gets an extra bonus if she sells a convertible or a car with leather upholstery, she is interested in the probability that you will buy a car that is a convertible or that has leather upholstery. Of course, if you bought a convertible with leather upholstery, that would be fine too. Pictorially, excuse me, I can't pronounce that. The shaded portion, right, of this image represents the outcome of satisfying the or condition. So notice that the condition for A or B is satisfied by one of the following conditions. Any outcome in A occurs, any outcome in B occurs, or any outcome in B of on A and B occurs. All right. So it's one or the other, right? Here's how I like to think about this. All right. So picture that we're like 6 years old because we're able to talk, right? And then imagine that like our parent asks us like, all right, for dessert, would you like cookies or ice cream? Right? We have the ability to say one, the other, or both of them together. Right? Both of them together is the right answer. but, but we have that ability, right? Like so that's what or is. Or is one, the other, or both. Right? I'm just gonna show y'all a quick little picture just to represent what I'm saying. So check this out. So remember before when we was doing what's the probability of A and B? I'm only interested in their intersection, right? I'm only interested in what is happening at the same time, A and B. But when I say or, what's the probability of something or something? I'm talking about the whole shebang, everything, right? It could be just the A, it could be just the B, or it could be just the both of them, right? That's the difference between them. Long story short, you see or, you think addition. That's it. Or is addition. So let me hit y'all off with an example before we take it up a notch. Trying to decide if I want to do this or not. All right, bear with me 1 second. Exactly. Exactly. All right, so check this out. A school club has 53 members, 30 members play soccer, 43 members play basketball, and 17 members play both, right? What is the probability that a randomly selected member plays soccer or basketball? Go ahead, do that real quick.
That's the same thing that we're doing with probability, right? The A and B.
Mm-hmm. No, not A and B. This is the or.
Oh, the order, okay.
Let me help y'all out. This is the formula that I want y'all to do. General addition rule for any events A and B, right? So we want to know what is the probability of A or B, which is equal to the probability of A plus the probability of B minus the probability of A and B. Try that out real quick. Try that out. You guys might be able to get it without my explanation, but I'm gonna explain it still.
But it ties in similar to like what we did,
It does.
oh,
Yeah. Remember, use the story. Use the story.
Professor, my bad, real quick, the fifty thousand like a fraction too?
It is a fraction. So remember, all probability is the events, what I'm trying to say, is success divided by probability. That's all probability. I don't know about the trying to do. Some basic thing like songs, we just have to, say basic things. Our favorite, there's a whole bunch. This is one company is called Boulder. Boulder. We have chips like they have like a sea salt one, but there's like a vinegar one as well, something like that. And then there's another one I like, I think it's called Good Something. I'm not to say health, but it's still something. But yeah, they have so much shit like that as well. Honestly, it's hard to find. So I live by a supermarket food town.
Yeah.
I live by a food town in Baytown.
Food town would be waiting though, because if you go to like key food or
I reached this point where like I started looking at like brands and their ingredients of what they use to make the food. And there's some supermarkets that are walking right now, and I would walk straight out. Like they got I did it recently at Seatown. I went to a Seatown supermarket, and I don't know who I was really looking for products. And there was nothing that turned my head. I walked right in. You know, I think the only thing I got it was some better sheets. Those particular chips and is the oil. They find how oil, olive oil. They have some red palm oil type of thing. That oil is so bad, you can't even go in the supermarket and buy it yourself. This is crazy. How we doing?
I didn't know about that rule yet, so
All right.
I just simplified that.
All right, let's take a look then, real quick. So watch what I'm gonna do. Watch what I'm gonna do. Let me get that highlighter real quick. So they asked us what's the probability of soccer or basketball right there, right? So use those words in your working, right? So I want to know what's the probability of soccer or basketball. And that's going to be equal to what? The probability of soccer plus the probability of basketball minus the probability of both of them.
But
You see that?
that's like connecting each one of the variables.
Exactly, exactly.
About hitting like that's when I talk about fractions.
Mm-hmm. So watch the fraction. What's the probability of soccer? How many people play soccer? So 30 over the total, 53. Plus, how many people play basketball? 43. Over the total, 53. Minus, how many people play both soccer and basketball? 17 over what?
53.
Exactly. And the rest of it is just calculator, you know?
That's when I don't know what it's like.
Yeah, you could just do the numerator, right? Let me do it real quick. So this is going to be 30 plus 43 minus 17. Just keep it simple. So 56. Wait.
0.56? Yeah, 0.56.
So this is 56 over 53. I want to make a comment on this. All right. So low key, I literally just copied this question, but you guys know that all probabilities are between 0 and 1, right? So this actually wouldn't even be a correct answer here, but our process is correct. All right. Let me try another question and then see if this one is better. Go ahead. You won't get the question like this. The one on the final is gonna be like nice. Like it's gonna work, you know? Yeah, but this is me like copying from Microsoft. One second. Let me just look at one real quick. Anybody copy it real quick? Let's see this. All right, here you go. I mean, he might have been smarter than me. That's what it is. Mhm. I'm still trying to come up. My fault, y'all. So if you look at this question real quick, this has more appropriate numbers. All right. Same question, right? It's just with better numbers. Your numerator should never be larger than your denominator, right? Because all probability is between 0 and 1. So if we do this one out, right? I'm just gonna do a little shortcut because it's the same story as what we had before. This would be 50 plus 77 minus 31 over 99. And when we do the math on that, we should get something like 96 over 99. I would accept this as an answer. You know? And that's it.
But you wouldn't touch it, it would just be like that.
I'm chilling with that answer. I'm good. Yeah.
That's what I'm saying, you.
Yeah. If you wanted to reduce it or give me a decimal, you could, but that's a good answer right there. I mean, ain't nothing wrong with that. You know? All right, real quick. Let me give y'all some procedure. This is how to use addition rules. So first, determine whether the probability A and B are mutually exclusive events, right? If the probability A and B is equal to 0, then the events are mutually exclusive, right? On your test, right, they will not be mutually exclusive. All right. If the probability, if A and B are mutually exclusive events, then you use the probability of A or B is equal to probability of A plus probability of B. No. This is you, number 3. If A and B are any events, that's what we have, any events, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. All right? That's it. Questions on this? All right, cool. Real quick before we move on, I just want to give y'all the meaning behind it, because maybe on the test, if you go blank, the meaning could help you figure out the answer. So what does the fact that 2 events are mutually exclusive tell us, right? If 2 events A and B are mutually exclusive, then we know the occurrence of one event means that the other event will not happen. In terms of calculations, this tells us that the probability of A and B is equal to 0 for mutually exclusive events. The probability of A or B is going to be equal to the probability of A plus probability of B for mutually exclusive events. The probability of A given B is equal to 0, and the probability of B given A is equal to 0 for mutually exclusive events. That is, if event B occurs, then event A will not occur, and vice versa. All right. Don't know if that's going to help, but you guys can look at that on the recording. Boop, boop, boop. All right. Last topic for today. We're going to talk about contingency tables. All right. So most of us have been asked to participate in a survey. Schools, retail stores, news media, and government offices all conduct surveys. There are many types of surveys, and it is not our intention to give a general discussion of this topic. Let us study a very popular method called a simple tally survey. Such a survey consists of questions to which your responses can be reported in the rows and columns of the table called a contingency table. These questions are appropriate to the information you want and are designed to cover the entire population of interest. In addition, the questions should be designed so that you can partition the sample space of responses into distinct, that is mutually exclusive sectors. All right. This is some good stuff here. So if the survey includes responses from a reasonably large sample, then the results should be representative of your population. In this case, you can estimate simple probabilities, conditional probabilities, and the probability of some combination of events directly from the results of the survey, right? This is about to be fire right here. This is about to be fire. Wait till y'all see. All right, here goes a survey. Here goes a survey. So at Hopewell Electronics, all 140 employees were asked about their political affiliations. The employees were grouped by type of work. As executives or production workers, the results with row and column totals are shown in this table. I'm about to show y'all right now. This about to be fire. This is our table right here. So employee type and political affiliation, right? So here we go. We got a different kind of employee types. You got the executive, the production worker, right? And then you have the different party affiliations, right? Democrats, Republicans, you got independents right here. Going straight across, we got our row totals. Row totals. When they say total, that just means you add them together, right? And then going straight down, we got our column totals, column totals, column totals. And then this right here, our grand total. All right. This is what's called a contingency table, right? And from that, I can ask you many, 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 many questions, right? So let me ask you guys one. What is the probability of a Democrat? And what is the probability of an executive? Go. I'm asking you what the probability of Democrat is. Percent, no. Nope. How many Democrats are there? 68 Democrats. Very good. And how many people in total? 140. Done. That's it. That's all I'm asking about. Let's try it again. Let's try it again. Right? What's the probability of an executive? 48. Good. Perfect. That's what I'm talking about. All right. Let's take a look. It gets a little tricky, but it's not bad. Yeah, that's it. That's the answer. That's two questions right there off the problem. So I asked you, what's the probability of Democrat and executive? So to find it, you take the total number of Democrats divided by the total number of everybody, right? 68 over 140. You do not need to give me that decimal or whatever. 68 over 140, good. That's it. All right. I asked you what's the probability of executives, right? All you do, you give me the total number of executives divided by the total number of everybody. 48 over 140, done. Right? You don't need to do the calculation in the calculator. I'm good with the fraction. Questions on this? Good? All right, let's keep it moving then. Just because I want the table, I'm going to erase this real quick. What's the probability of a Democrat given an executive? Give me the answer there. 5? No, it's a fraction I'm looking for. Something over something. Say it again. Close. Close. All right, let me ask you something. How many executives are there? 48, right? So there's 48 executives. Now, out of all of those executives, how many of them are Democrat? 5. That's my answer. That's it. So whatever comes after the given is your denominator, right? And before the given is your numerator. That's it. Does that make sense? Let's take a look at that. So to compute the probability of Democrat given executive, for the conditional probability, we restrict our attention to the proportion, the portion of the sample space satisfying the condition of being an executive, right? So we look at the executives, the total number of executives, which is 48. And out of all of those executives, only 5 of them are Democrats. So 5 over 48. And that's it. Again, you don't need to give me the decimal answer, whatever. I know y'all all have calculators. I'm good with the 5 over 48. That's it. And that's that. Let me see what else I could ask y'all. What's the probability of Democrat and executive? Over. That's what I'm talking about. All right. Democrat and executive at the same time. So how many people are Democrat and executive at the same time? Only these five right here. Right? Over the total. All right. Make sense?
So is it always gonna be over the total?
Always. Always. Except in the given situation. Right? Real quick. So the probability of Democrat and executive, this probability is not conditional, so we must look at the entire sample space. All right. It means over the total of everything. So the probability of Democrat and executive is the number of executives who are Democrats at the same time. Right. So that's the five over the total of everything, 140. All right. And then we have some other dependent stuff here. Don't worry about that. All right. You guys did great on all of this. So now, what's the probability of a Democrat or an executive? Go straight to your formula. You don't even got to think about this. What's the formula for or? Addition, right? So this is going to be the probability of Democrat plus the probability of executive minus the probability of Democrat and executive. So what's the probability of a Democrat? 68 over what? 140. Perfect. Plus, what's the probability of an executive? 48 over 140. Minus, what's the probability of a Democrat and an executive at the same time? 5 over 140. And then just a little calculator. 68 plus 1, excuse me, 68 plus 48 minus 5, what's that? 111 over 140. And that's it. Questions on this? I bet. So we all gonna get 100 on the contingency table, right? In my opinion, this is the easiest question on the whole final. Don't get it wrong. The OR formula, always. Real quick, let's talk about this, then give y'all another example. So the results using the rules are consistent with those using the sample space. So compute the probability of Democrat or executive, right? So from part D, we know that the events Democrat and executive are not mutually exclusive. So because the probability of D and E is not zero, therefore, the probability of Democrat or executive is equal to the probability of Democrat plus the probability of executive minus the probability of Democrat and executive, right? Plug it in, 68 over 140 plus 48 over 140 minus 5 over 140, 111 over 140. You don't got to give me the decimal. I'm cool with the 111 over 140. All right. So that being said, just bear with me 1 second. I'm gonna go for like a 5 minute walk, but y'all do this real quick. Knock that out real quick. I'll be back. Actually, wait, I gotta do something over here. Damn, I can't. Right back.
how we do this. So for the lag,
Yeah.
right, so it'll be 45 over 180. Right?
All right. So probability of black is equal to 45 over 180. I agree.
That's all right, right?
Yep, that's good. That's all I want.
Okay.
So what about probability of truck or red? Oh, wait, I'm sorry, truck and red. Whoops. $15 over 180, good. SUV, 35, 80, good. Over 180. No, come. No problem, no problem. What about D? So given that a car is blue, what's the probability it's a sedan? No. No. What is it? No add up. Just give me the answer straight. 30 over 60. That's it. So what they're asking you in D, I want to know what's the probability of sedan given blue, right? Now, out of how many blues are there in total? 60. And out of those blues, how many of them are sedans? That's a 30. So 30 over 60. That's what that is. All right. All right, last one, right? I want to know what's the probability of black or SUV?
25.
So, so real quick, it's probability of black
Well, she got it.
plus probability of SUV minus probability of both. I ran out of space. That's why I'm doing it like that. So black is what? 45, good. Over what? 180, good. Plus, what's probability of SUV? 80 over what? 180, good. And then minus, what's the probability of black and SUV at the same time? 25
I'll give you 100.
over 180. Perfect. Hold on. I don't even have enough space. 100 over 180. All right, questions on this? This is our contingency table right here. All right, so just to recap, right? We have now, even though this is day 2, we have now gone over half of your exam. If all you did on the exam was these 4 questions, that's a 50. All right? Gucci. All right.
How many questions are in the exam?
8.
8?
Mhm.
This is 8 questions, that's it.
Mhm.
Oh, nah.
Mhm.
Oh, nah, give me the third.
I still don't have a confirmation on homework for y'all,
Oh,
but watch the video over. Look at your homework from the semester, right? But I don't want you looking at all of the topics you did for the semester. Only look at what you see me doing with y'all right now,
okay.
right? So if you see me skipping some stuff, there's a reason why I'm skipping it. It's because it's not on the test. All
Okay.
right. All right.
So don't email us, right? If,
Yeah. Good.
So we back here tomorrow.
Yeah. Back here tomorrow
In person or online?
in person.
In person.
If it's online, what I would do is I would probably just email you like a Zoom link,
Okay.
and then but I'd probably still be in person.
Okay.
Kind of nonsense.
I don't know.
Yeah. I mean, but technically speaking, y'all all signed up for in-person classes, so that's why I want to respect y'all and still show up, you know? So, yeah.
The possibility of like, if it's like a question already,
Yeah,
you basically have the course.
pretty much. But we going for 100 though.
I don't know.
Yeah, yeah. Oh wait. Hold on. Yeah, wait, hold on. Remember, we just gonna talk, remember? Yeah,
Oh, yeah.
yeah. All right, so I can stop the recording. We good? All right, cool. All right, I'm gonna email it to y'all.